everyone. This is problem 64 of Neetcode 150, kth largest element in an array. So in this problem, we're going to be given an array of integer nums, and we're also going to be given an array, an integer k, pardon me, and we have to find the kth largest element in this array. The array that we're going to be given won't be sorted, so this is one of the challenge, and also we cannot use a sorting algorithm. All right, so otherwise it will have been quite easy. We'll simply sort it and return the element um, at the value length nums minus k. But in our case, we can't, so we're gonna have to find another solution. Let's take a look at the example one. See that we have an array with the number 2, 3, 1, 5, and 4, and we have to render the kth largest element. So if we just go take a look at the array and pick the largest element, you will see that it is that value 5. And after this, the second largest element is 4. So we will have to return 4. Okay. In the example 2, we have an array with the value 2, 3, 1, and 1. Notice it duplicates 5, 5, and 4. Okay. So in this problem, duplicates count, they don't count for one values. For example, the largest element is 5, and the second largest element is also going to be this 5 here. It's duplicate. And the third largest element is going to be 4. All right. So there are two ways to solve this problem. The first one is to use a max heap, and the second one is to use a min heap. We will go over both solutions, but let's first show the reasoning behind using a max heap. So a max heap for this array containing 2, 4, 6, 3, and 7, we'll first start with our 7, then we'll have our 6, we will have our 4, and then our 2, and our 3. So we know that if we keep popping the top values, we will have eventually the kth element if we pop k times. So if we pop the 7 in the maximum value is going to go to the top, because this is the concept of a max heap. So it will go like this, and then we will pop again, so it will look like this. 4 is going to go on top, here. All right, so this will be the concept. So if you want the second largest element, we know that it's going to be the 6, or the second value that we popped out of the max heap. Okay, so this is the logic using max heap. I would just like to bring to your attention that in Python, max heap does not exist. So we have to use a min heap, but to do so, we just have to convert each values to their negative values. So we have to multiply 3 values by -1. So the maximum value, when it's going to be multiplied by -1, is actually going to become the lowest value. So we can use a modify min heap to accomplish a max heap. With that being said, I would like to jump on the logic for using a min heap. So when we use a min heap in our problem, we are going to have the minimum value at the top. So if we use a min heap for the entire array, we will have 2. Okay, but in our problem, we want to basically take like if we have a k value of 3, we want to take the 3 largest element and make sure that our min heap is composed of these 3 largest elements, and then we just have to return the top value, which is the lowest value among these top 3 elements. So what we're going to do is that we are going to start building our min heap, and at each value we are going to add it to the 3. All right, so we're going to keep doing this. Now we have a 4, and the 4 is smaller, so it's going to go down. It's going to go down the 2, excuse me. Then we have 6, and 6 is also greater, so it's going to go here. Then we have 3, but 3 is actually is actually smaller than our value 4 and our value 6, so it has to go between the 2 and the 4. But notice that if, for example, our value here is for the k is 3, it must mean that we have to stop adding numbers to the tree and we have to remove the smallest number. So in this case, we will just remove the 2 and make sure that the 3 goes at the top. All right, and after the 3, we're going to add the 7. So what we do when we add the 7, we are going to have to basically once again pop out the smallest value and then add our 7 value at the right position in our min heap. Okay, and then once we are done, we can just return the top value, and that top value will be your kth smallest element. All right, so let's go ahead and try to create the max heap first. So first we have to make sure that every values is going to be multiplied by -1. So what I would like to do is simply say for I in the range of the length of the nums. So we can actually go through every index, and we're going to set basically that value to its negative counterparts. All right. So once this is done, well, we can create our max heap or modify min heap. That's going to give us our max heap. And what we're going to do is that we're going to use the heap2 library and use heapify to create our min heap. So we're going to say heapq dot heapify, and this is going to create a min heap with our values in a time complexity of big O of n. All right, and after this we are going to pop all the values. So what we're going to do is that we're going to use from the same library heapq, we're going to use the function heap_pop. So this is going to take the top value, which is the smallest one, but notice that the smallest value multiplied by -1 is actually the greatest value that we have in our nums. So what we're going to do is that we're going to say while k is smaller than 1, we are going to use our heapq dot heap_pop on the nums, and then we're going to decrement our k by 1. So after this, let's say that our k value is 3. Our while loop is going to have pop the top value 2 times. So we know that the top value is now the smallest element, or the kth smallest or the kth largest element. So we can simply return this value multiplied by -1, right? Because we recall that we initially changed all our values for their negative counterparts. So we're going to return its negative counterparts as well to get back its original value. So we're going to say heapq dot heap_pop the nums. Okay, and this is it. So let's test that out. This is the solution using a max heap. Now let's see how we can that using a min heap. So for a min heap is always going to have to be the length of k. If it is larger, we're going to have to pop the smallest value in the min heap. So we're going to go ahead and create our array of min heap, and we're going to say that we're going to go for each number in nums, and we are going to push this value inside our min heap. So we can do this with the same library heapq with the function heap_push. So we're going to say heapq dot heap_push, and we want to push into min heap, and the value you want to push is that particular number. And after this is pushed, we want to make sure that we want to handle a case where the min heap is actually larger than k, and in this case you want to use from the library heapq the function heap_pop on that min heap, and that function epop is going to pop the smallest value. So we're going to be left with still the three largest values in the case where our k is 3. And after this, we can return the first index, so the element at index 0, because this is the top value or of our min binary tree, or in other words, it is the kth smallest element. So we can go ahead and submit this, and there you go. All right, so I hope you learned from this video, and I hope to see you in the next one.